All right, welcome to using your inverse matrix to solve systems of equations. So we're definitely going to want to use your calculator for this technique. So what we need to do is first create three matrices. Matrix A, matrix X, matrix B. Matrix A is your coefficient matrix. Very similar to matrix D in the Cramer's rule that was in the denominator. So 1, 1, negative 1, 3, negative 2, 1, 1, 3, negative 2. Your variable matrix is just the variables that is given in the system, x, y, and z. This just lets us know what variables we're solving for. B is the result matrix, what all your equations are equal to. So 6, negative 5, 14. All right, so you probably recognize this from when we did the Cramer's rule. It's the same system. So to use your inverse matrix method, what we do is we create what we call a linear matrix equation. Matrix A times matrix X equals matrix B. So let me show you how these two multiplied together being equal to B creates your system. Row 1 times this column has to equal 6. 1x plus 1y plus a negative 1z equals 6. That's this equation. 3 times x plus negative 2 times y plus 1 times z equals negative 5. Second equation. 1 times x plus 3 times y plus negative 2 times z has to equal 14. Third equation. So what we want to do is basically solve this for x by getting rid of matrix A being multiplied to my x. So to do that, we can multiply matrix A by the inverse matrix, but we have to multiply it to the left side of A. And if that's the case, you have to multiply the inverse matrix to the left side of matrix B. All right, whatever side you're multiplying is important. Remember, you got to get those dimensions have to line up where the two middle numbers are the same and we cancel out. Well, this is A inverse is a 3 by 3. A is a 3 by 3. We can multiply it. This cancels out to the identity matrix. 3 by 3 times 3 by 1. This will cancel. The 3's cancel, leaving us a 3 by 1, which will give us the answers for x, y, and z. All right, so technically, here's what we have to get our calculator to do for us. So multiplying these two together is just multiplying A inverse times B. So we're going to store matrix A. We're going to store matrix B. We'll go inverse of A times B in our calculator, and we'll get our answer. So go ahead and store A. Go ahead and store B. So pause it. Get those stored. Okay, welcome back. So one of the things that my math lab will ask you to do is to find the inverse of matrix A and enter it as your answer. So A inverse, go to your calculator. I've stored the A matrix as a 3 by 3. Now, what I have a tendency to do is I've noticed that a lot of inverse matrices are always in fractions. So always put math, return your answer as a fraction in your calculator, and hit enter. So here is a bunch of fractions. So what you're going to do is you're going to go to all 9 text boxes in my math lab and enter these fractions. And what I recommend that you do, because you have so many denominators of 3, I would type in, go to this text box first. Type in 1/3. Type it in, copy it, and go to every text box and go Control V, 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 Control V. Paste them in. And then just go alter the signs or the numerator. So that 1/3, now make it a negative 1/3. Oh, make this one now negative 7/3. 1/3. Make this 4/3. Negative 11/3. Change the numerator to a 2 and a 5 and you're in business. Okay, I'm just going to copy my screenshot. Now, remember I said earlier, this is the same coefficient matrix that we used with Cramer's rule. So if you take the determinant of matrix A, that's that same -3 that we put in the denominator in Cramer's rule. So again, that -3 is occurring in all these denominators here. Well, if your coefficient matrix is going to give you a 0 for the determinant, all 9 denominators are a 0, we won't have an inverse matrix. I think the calculator calls it a singular matrix. And if that happens, we can't solve the system. All right? So we go to our calculator, take A inverse times B, and we get 1, 3, -2. So that means x is equal to 1, y is equal to 3, z is equal to -2. And you type in your ordered triple just like we had when we did Cramer's rule. Okay? All right. Now, that -1 right there, that's the matrix button. So you're going to hit x to the -1. So I'll show you that in just a second. Just to recap everything, we had 3 ways to solve your systems. The Gauss-Jordan, which is the RREF, Cramer's rule, inverse. Gauss-Jordan is by far the best technique to use. If it was me, okay, I would do everything by RREF, even if they asked me to do Cramer's rule, even if they asked me to do inverse matrix. Type it in as an augmented matrix, do an RREF so you know what the answer has to look like. Then do your Cramer's rule, do your inverse, whatever you want they ask you to do. But if you notice in the RREF, if the bottom row is all zeros or 3 zeros and a non-zero, then you know your determinant is going to be a 0 and there's no way to find the solution. So when you're in my math lab and working with Cramer's rule or the inverse method technique, and I do RREF first and I see that it's no solution or infinite solutions, just choose the option the answer can't be determined, and you don't have to waste your time looking up the determinants or the inverse matrix. Okay? So, to the calculator again, just to show you. Calculator, where are you here? I got you down here somewhere. There you are. Let me bring it back over here. Okay, just so you can see where everything is at. This is your inverse button. Okay, so again, we used matrix B just to show you. Matrix B. There's that 1, 1. Whoops. I got to go change that third column, don't I? Darn it. I forgot to do that. So I'll go edit. Let's see, we had one, that's a -1, down arrow, then a 1, down arrow, then a -2. Wait a minute, oh no, what did I do? Oh, I goofed things up here. 1, 1, -1, 3, -2. Oh, that needs to be a -1, right? Or a 1 right there. 1, 3, that needs to be a -2, so I must have missed the down arrow. There we go. Just a quick double check. Yep. Okay, so like I said, second quit. Let me clear out my screen. Second matrix, ask for matrix B. Put this x to the -1, that's asking for the inverse. Math, return your answer as a fraction. And there's all those fractional answers. So that's how you let your calculator find your inverse matrix.